Hi everyone. So right now I'm assuming that you guys have already everything about acids and bases crystal clear for you, which means that you might be able to tell me the definition of acids, the names of few common acids. You'd be able to tell me the differences between strong and weak acids and predict the pH of those chemicals as well. You'd be able to tell me what observation happens or what are the products when acid reacts with a metal or a metallic carbonate or an alkali or a metal oxide, and you'd be able to list down the name of the salt as well based on the name of the base and obviously the acid. So we're going to jump off to the idea of bases. We did revise it in the previous video, so we know that bases neutralize acids. There are two categories of bases. We know that one is the insoluble ones, we call them the insoluble metal oxides, and the other one was the soluble alkalis. I'll have to move it because of obviously for the OCD reasons. Okay, and the arrow comes here. TKG. Insoluble metal oxides obviously do not dissolve in water, so they do not dissolve in water. But the alkalis dissolve and dissociate in water. They dissolve and dissociate in water to give you the OH plus OH minus ions. Dissociate in water to give OH minus ions. Insoluble metal oxides are generally magnesium oxide, calcium oxide, aluminium oxide, zinc oxide, iron oxide, lead oxide, copper oxide, and silver oxide. These are the possible metallic oxides that we generally deal with, but the alkalis are only four. So it is lithium hydroxide, sodium hydroxide, potassium hydroxide, and ammonium hydroxide. Ammonia means NH4 and hydroxide is OH. So alkalis or bases have two reactions. Number one is obviously neutralization reactions. So the first thing they do is neutralization. We know that they react with acids to make salt and water. So H plus from the acid reacts with the OH minus from the alkali. H plus from the acid reacts with the OH minus from the alkali to give you H2O. So this is neutralization. We already have talked about it. The second reaction they do is with ammonium salts. Ammonium salts. So ammonium salt would be any chemical which has ammonium ion in it. For example, ammonium nitrate. It could be ammonium chloride. It could perhaps be maybe ammonium sulfate. Ammonium has a +1 charge, so you can predict how we get the idea of NH4 2SO4. Ammonium is again a polyatomic ion. Ammonium basically looks like this. So it is 1N with 4 H's, NH4, and obviously there's a bracket which has a +1 charge. So NH4 has a +1 charge, and we create the formula based on the charge. So whenever you see NH4 salt reacting with a base, for example, let's say NaOH is the base over here. So what happens is that NH4 is pretty unstable. So you will get two things out of it. You will get NH3 and you will get H. Now NH3 is a gas which is known as the ammonia gas. H has a charge of +1. NO3 has a charge of -1. NaOH, sodium hydroxide, has Na with a charge of +1, OH with a charge of -1. We again do the partner exchange thing. So Na goes with the NO3, the OH goes with the H and makes water. The last thing is the ammonia gas, which is a solid, which is like it's the pure product. So you get ammonia gas. Let's try out with NH4Cl. and let's suppose we have the we have the alkali of maybe lithium hydroxide. Again, NH4 is unstable, so it gives you NH3 gas and gives you one H. Now we know that H is plus, Cl is minus, lithium is group 1 metal, so it's plus, OH is minus. Putting it at a lower, like moving it a little lower. I'll move the charges as well. Let's move it over here. ठीक है जी. The Li goes with the Cl because again a partner exchange thing. It becomes LiCl. The OH goes with the H and gives you water. The last thing is the ammonia gas. So you release out ammonia gas in this case. So it's always a partner exchange reaction where the metal part goes with the non-metal part and makes a salt. Similarly over here, the H, maybe the H goes with the OH to give you water, and you get ammonia gas, which is a pure compound. So you get ammonia gas like this, which is a pure compound. So you get three products from ammonium salts reacting with a base. Let's try one more example. Here we are not using an alkali. We could be using a metal oxide. For example, let's be using maybe calcium oxide. Let's move it a little. Again, NH4 means that it's a combination of NH3 and H. H has a charge of +1. Sulfate has a charge of -2. Calcium is +2 because it's group 2, and oxygen has a charge of -2. Again, we swap the products. So SO4 goes with the calcium. It gives you calcium sulfate. The oxygen comes with the H, and O and H combine to give you water. Ammonia is the last product that you get. So it's again a partner exchange reaction, and you get water from the you get basically a salt, because I'm using yellow for the salts right now. So calcium and sulfate combine to give you calcium sulfate as a salt. H and OH combine you to give the water, and what else you're going to get is you're going to get ammonia gas. So ammonia gas is the third product. So whenever bases react with ammonium salts, you get ammonia gas, water, and a salt. Obviously the salt largely depends on what kind of base you were using, and it depends on what kind of ammonium salt you were using. So again, the salt depends on the initial reactants rather. And obviously alkali metals make alkalis which are soluble in water. They partake of the neutralization reaction. You get a water molecule from the H plus charge and the OH minus charge. So neutralization and ammonium salts are the two things that we might want to remember for generally all the basic reactions, all the alkaline reactions. So let's keep it till here, because bases are done, acids are done, and in the next video we'll be talking about salts in particular. So we'll be jumping on what salts are and what are the various methods of making salts.